As you probably know, the Donut Lab solid-state battery has been everywhere at the minute. There's lots of discussion around it, and when I was in CES the other week, I was feet on the ground, reporting, trying to find out as much as I could, but there was limited information, so now I've got more information. I want to share everything I've seen so far, everything I've heard. I've been watching videos, listening to discussions. I've even had some people from Finland reaching out to me with additional information, some anonymous informants, which makes me feel like a proper journalist. But it has been crazy, and thanks to the popularity of the first video, I've received a whole lot of information, and I want to pass that all on to you. So let's get into this and see what we found. I'm Ryan Innes, and this is a Zeroth Deep Dive. So what I've seen online, there's kind of two main prevailing theories, which I split into capacitor theory and battery theory, and they kind of mulled into each other a little bit, but we'll get into that. I also want to emphasize how huge of a breakthrough this battery would be, not just for transport, but for the whole world. If this battery could truly last 100,000 cycles, it would mean the average cost of storing energy could be around 20 times cheaper than it is today. This is based on the levelized cost of storage, which accounts for how long the battery lasts, because who cares if it costs twice as much up front if it lasts your whole lifetime? This huge cost reduction would mean almost everything goes electric. Every truck, every home. This would be immeasurably huge. One of my main interests as a person is electric propulsion, and specifically motorcycles. I mean, I've spent months of my life traveling on a motorcycle, living out of a tent, and even then, I think that's probably the least interesting use case for this technology. Beyond the battery science, there's also discussions on the wider company's legitimacy, which I'll get to at the end of the video. There are many theories flying around right now, and I want to look over them and see if anything can explain this magical battery technology. So the main technologies discussed in this video are batteries and capacitors. So just a quick overview of what those are seems useful at the start. At a high level, both batteries and capacitors have an anode and a cathode, but they play very different roles. In a battery, the anode and cathode are made of different materials that store energy through chemical reactions, with ions moving between them during charge and discharge. And this is what allows batteries to store large amounts of energy. And in a battery, in between the anode and cathode, you have a separator. For solid-state batteries, that separator is solid, and it's there so you can use high energy density anodes like lithium metal, and the solid electrolyte should prevent dendrites from growing, which means the battery has a reasonable lifespan without degrading. In a capacitor, the anode and cathode mainly act as conductive plates that hold opposite charges with little or no chemical change, which enables extremely fast charging and discharging of electrostatic charge, but with much lower energy storage capabilities. And I know you've probably heard them loads of times, but it's probably worth just quickly running through the claims from the Donut Lab battery as well, just to give context. So they claim a 400 watt-hour per kilogram solid-state battery that could last 100,000 cycles and recharge in 5 minutes. They also say there's no lithium or toxic materials involved. From speaking to them, they said that the battery operates at 4 volts but could be changed to meet any voltage need, and they also said it can be made into any shape and made at small-scale modular manufacturing places. Now, these are really, really wild claims, and I think for me the biggest claim is the 100,000 cycles, because what I mentioned earlier about how that affects the lifetime levelized cost of the energy storage. We've seen really high energy densities before. I mean, 400 watt hours per kilogram is definitely on the upper side beyond most state of the art, but it's within conceivable limits, especially for solid state batteries that have lithium metal anodes. However, to have that battery last 100,000 cycles is a whole different kettle of fish. Also, it being 4 volts is pretty standard, but the fact they say it can be made to fit any voltage is very strange and definitely much more like a capacitor, as is the 100,000 cycle life. As a quick bit of housekeeping, I also got a message from someone with connections near to Verge Motorcycles, which is in Estonia, and out there is a supercapacitor company called Skeleton, but they spoke within the team that they know out there, and there's no connection between Donut Lab and Skeleton, at least not for this battery project.
There appears to be some debate online, but I can confirm that this battery is linked to the company Nordic Nano due to some confidential investor notes that I've been sent. As a reminder, that's the company that had a capacitor in an investor pitch, which had very similar specs to the Donut Lab solid-state battery, meaning I thought that they would be connected in the first video. They appear to use carbon nanotubes to explain many of their innovations, which have been linked to the company Graphene Oxide in Germany. Okay, now on to some of the prevailing theories about the Donut Lab battery.
As I mentioned earlier, Ricky, my friend from the channel 2-Bit Da Vinci, actually did some digging as well. Some other people online also found this, that there was papers showing high energy density supercapacitors. They're kind of pseudo capacitors, so they use some capacitance and some electrochemical storage in a bit of a unique way to allow potentially some of the requirements to be met. And this was definitely in line with what I was kind of thinking, so I looked into this a bit more. The paper introduced a new kind of fiber-based supercapacitor that can store much more energy without losing the fast charging and long lifetime properties that supercapacitors are known for. Instead of having the energy storage material only on the surface of the capacitor, the researchers bonded it directly to carbon nanotubes and they span everything together into a single fiber, which meant the entire fiber could store energy, not just the outside. Now, I'm definitely no expert on capacitors, but this was a super interesting and promising lead. The fiber stored charge in two ways at once, so electrostatically on the carbon nanotubes and through very fast chemical reactions in the polymer that was lining it. Because these reactions are so quick and reversible, it kind of behaved like a supercapacitor but had the energy storage more like a battery. The result was a flexible, durable fiber that delivered extremely high power and energy densities, and it kept working after tens of thousands of charge cycles, giving them an interesting bendable and foldable storage system. However, thankfully I still have my university affiliation from doing my PhD, and I had a deeper look at the paper, and what was quoted was, I think, 418 watt-hours per kilogram, which seems very in line with Donut Lab's claim for their battery. And on top of that, the high cycle life, this seemed very promising. But that 418 watt-hours per kilogram actually only referred to the active material, not the whole supercapacitor. So I ran some rough calculations, saw what people were saying online, and it seems like you can lose a large percentage of the storage ability once you turn that just from active material into a full storage system, supercapacitor or pseudocapacitor. And by doing that, the energy density drops much lower to maybe more like 50 watt-hours per kilogram, which is very, very high, but, far off the solid-state battery claims. As a side note, this particular one also used some gel and liquid in the electrolyte, so it wouldn't have even been solid-state. I also found a cool Nature paper that described a new type of anode that uses very small titanium oxide particles that can be used to store sodium ions through surface redox pseudo capacitance. Therefore, you again have the benefits of high energy density, but also the fast discharging and high cycle life of a supercapacitor. From some research that MissGoElectric and the team there discovered that this titanium dioxide use was also in line with some of the expertise from a chemist inside Nordic Nano. I thought that because the anode is storing energy mainly capacitively, it would be able to last the cycles required and the aging associated with ions going in and out of the material might be less of a problem. And this is also easier to manufacture than the idea that was presented by Ricky from 2-Bit Da Vinci. They even did a lab-scale mock-up, which I'm not sure if it was simulation or a real lab experiment, but they looked like they could get up to 300 watt-hours per kilogram energy density with this. But I think the cathode was a non-realistic material, so when integrated into a battery and all the other realizations of the real world came true, it would be far from the 400 watt-hours per kilogram that Donut Lab claim. I think this pseudo-capacitor ideas were some of the best ones I saw because it gave a kind of light at the end of the tunnel that maybe it was possible because there were some interesting reactions here that I'd not seen before. And then I read some articles and found a Finnish newspaper that said the CEO of Donut Lab completely wrote off the idea and said, this is flat out not a capacitor, not a pseudo capacitor. This is a battery with new systems in it that have not been seen before. So I thought these theories were really good, but I need to nip them in the bud for this system, which is a shame because I was enjoying looking at pseudo capacitors. So part of the reason I'd kind of ruled out it being an actual battery was, one, the early signs that the Nordic Nano team were working on capacitors, but also that the voltage of the battery they presented, one, was not the voltage you would expect from a sodium-ion battery, and they said there was no lithium. And also they said the voltage could be adjusted to whatever you want, and that definitely didn't align with what I understand as batteries. However, MissGoElectric and the team looked into the possibility of what materials might be used for batteries, and they did some incredible research, and it was actually quite good because I think maybe I'd got stuck in my box of capacitors, and they gave me a bit of a new insight on other technologies that could be used here, and it was a great watch. I'll leave links to their stuff down in the description. An overview of what they presented was using an anode-free design, but in place of where the anode is, they had these nanotube forests, which would allow the ions to sit more uniformly in the anode position as it formed and not create dendrites that would spike and age the battery, therefore improving battery life. And they went for a sodium-based cathode that's strengthened by a sort of network of carbon nanotubes. They used the example of rebar in concrete. This is such cool research, and I really enjoyed seeing their thought process and hypotheses on this. However, for me, the fact it's got sodium on the cathode side just means that the cell voltages present would not be aligned. The electrochemical potential, or I think that's what it's called, of sodium and the sodium cathode that they are presenting versus the anode or the anode-free side would not be enough to get 4 volts and definitely wouldn't be changeable. So from the voltage, this didn't seem viable to me. However, I wanted to get past the voltage because maybe there's some other interesting stuff we can learn here that is still relevant. Also, on the topic of voltage, I wanted to mention something that Dr. Juho Heska mentioned to me in a call that we had. He's written papers on solid-state batteries and has a PhD in chemistry and is from Finland and knows the industry inside and out, so he was a super valuable resource here. We discussed the design, but he also found in the test footage from Donut Labs that at 0% state of charge, with no load at the open circuit voltage, he saw that the battery had a voltage of 2.8 volts. And this is important because that is the same open circuit voltage you would expect with lithium ion. Now, they will say that you could tune this to whatever voltage you want, but I can't get that out of my head. But we're going to park it to one side just to explore the hypotheses that MissGoElectric put forward. One idea they presented is that by having titanium dioxide on the outside of the coaxial nanotube forest, that it will protect the aging and help with the interactions between sodium and the carbon. So one thing they mentioned was that they could coat the carbon nanotubes in a titanium dioxide layer, and that might help with the stability and stop dendrites forming and help with cycle life.
However, this reminds me of artificial solid electrolyte interfaces, which are already used by many battery manufacturers, including CATL, to increase battery lifespan. It's been successfully used, but nothing close to 100,000 cycles. Nevertheless, the MissGoElectric team found an interesting paper about the reinforced sodium-based cathode.
And it looks very promising. The energy density is very high. I've got the figure here of 472 watt-hours per kilogram. However, like with the pseudo-capacitors, this is the energy density of the active mass, which is of the cathode, which means when you stack everything else together, the housings, the current collectors, all of these things, that drops considerably, well below 400 watt-hours per kilogram, which makes sense because sodium ions are generally not known for giving you high energy-dense batteries. Also, the nanotube anode forest, which I love as an idea. I also spoke to Dr. Juho Heska about this carbon nanotube anode forest. The idea presented by MissGoElectric was that it would be coated in titanium dioxide through atomic layer deposition, which is a competency from a chemist at Nordic Nano. However, Dr. Juho Heska said that from his own experience, atomic layer deposition, or ADL, can be a very difficult process and does not align with the easy manufacturing aims that Donut Lab have put out. I would say that if there has been a crazy breakthrough that happened behind the scenes, it wouldn't likely be in the public domain anyway, which means that it's hard to trace what they might be doing, because otherwise battery giants like CATL would probably have already tried it. The voltage and cycle life just simply don't align with a sodium-ion battery, or any other battery system in the known literature. Batteries also can't select their voltage, and this is governed by electrochemistry of the materials. I was really holding out some hope with the pseudo capacitor theories, but with that out the window, I'm not really sure where I stand. I've seen the documents that confirm Donut Labs is linked to Nordic Nano, and they have made a few claims that are of concern. One includes a presentation where they talk about scaling up batteries from micro batteries. But as I've learned, scaling things from a micro battery to a large scale battery really changes the physics a lot. This means you can't transfer what works on a micro battery into a large-scale automotive one. So it's been about a week since I recorded the first section of this video with the bad lighting in the hotel room, and there's been a few updates that have come through, and I just wanted to summarize this whole thing and kind of park this topic. Zeroth as a channel really focuses on science and technology, and I really want that to be the emphasis of this video. And my conclusion is that there's no known science in the literature or otherwise from everyone that I've spoke to that supports these claims as being possible, which means I have to give it a very small likelihood of being real just based on what is currently available to me in the literature. But that is the science side of it, and that's really my wheelhouse. However, it would be amiss not to mention some new information that's come up on the slightly less scientific and more business or political side of this topic. The first point on this are from some points that an investor and poker player in Finland made during a podcast. I saw an English summary from Quantum Works Corporation on LinkedIn, and here are some main points. They said that there was cold calling of investors and urgency tactics which can prevent proper due diligence. The investor also pointed out the fact it was a small team and that the investment structure was slightly strange, with promises of 5x returns in very short periods of time. This is just what the investor said, so we'll have to take it at face value, but it does align with some of the private documents that I've been sent too. The Finnish battery scientist Juho, who has been super helpful in this whole investigation, and I'm really sorry that I messed up the audio on the call so it couldn't be included in here, but he sent me an article by a Finnish news site. The news site points to an audit of Verge motorcycles by large accountancy firm PwC and the fact that they are plunged into financial crisis. The impression I got from this was that the accountancy firm tried to do an audit of Verge motorcycles and there just wasn't enough information to even do one, which is really not a good sign. One of the world's largest battery manufacturers in China, called Svolt, also put out a pretty scathing review saying that they just don't see this as being possible either. Of course, I still want this to be true, but given all of this information and the fact that none of the science I can find backs it up, we have to give this a very low probability. One thought I had on this is, if the batteries turn out to be false, how did we get to that position anyway, and what does it mean for their electric motors, which I know are real systems that are being tested and are on the Verge motorcycle now. We're just going to have to see how this plays out. The next 6 months are going to be very revealing and gives it a bit of time for some manufacturing delays if this does turn out to be true. This has been a really interesting investigation and I hope you've learned something new because I definitely have. And if you enjoyed this video, please consider subscribing. It's free and helps the channel a lot. You might also like some of my other videos like this one on a really efficient dual rotor electric motor. And as always, thanks for watching.